Hey guys, this video is going to go over how we can curve sketch using the derivative. So this is something that I've noticed that doesn't get taught much in class, and it's kind of taken as assumed knowledge when you do differential calculus. So the most important part is this is an application question. So you can kind of start to see how these questions are going to be applied and how you can apply your knowledge from differential calculus into graphing the derivative. So the main points here is that if we have a look at this table, we know that the derivative of f of x is going to be greater than 0 when our graph is going to be increasing, and f dash x is going to be less than 0, so below that x-axis if it's going to be decreasing, if our f of x is decreasing. So let's have a look at what this table says. Like we were just saying, if the graph of f of x has a negative gradient, that is that the graph is going downwards like this, we say that it's going to sit below the x-axis. If it has a positive gradient, so the graph is going to be on an upward slope like this, we say that it's going to go above the x-axis for your f dash of x. If we then have a look at our different points here, so we have, if the graph of f of x has a minimum stationary point, that is your graph looks like this, a concave up graph that has a minimum stationary point, we know that it passes through the x-axis from below to above. So we know that whenever there's a stationary point, f dash of x is equal to 0. But if we have a look at this, a minimum or a maximum stationary point, that's going to help us to see what part of the x-axis it's coming from. So if I draw this here, a minimum stationary point passes from below to above. So the graph was decreasing here, but then it becomes increasing, which we can see here. The graph of a concave up parabola was decreasing, and then it increases. Opposite for the next point here, if a graph has a maximum stationary point, we know that it's first going to be increasing, and then it turns to decreasing. So it's first above the x-axis, and then it goes below the x-axis. So that's going to look something like this. We then have what happens to our graph when we have a point of inflection. So if we have a stationary point of inflection, that is that f dash of x is equal to 0 and f double dash x is also going to equal to 0, the graph touches the x-axis and then moves away again. So our graph is going to look like this. It touches it and then it moves away again at this particular point. If it has a non-stationary point of inflection, so just a regular point of inflection, so where f double dash x is equal to 0, but f dash x isn't necessarily equal to 0, we say that it has a maximum or a minimum value. So this here is our turning points. So if we have a look at this example question, we can see how this information can then be applied. So we have the diagram shows a graph of the function y is equal to f of x here. So for part I, we need to find for which values of x is the derivative f dash of x negative. So if I draw my arrow so I can see where my function's gradient is positive and where my graph is increasing or decreasing, that's going to help me to answer this question and then to graph my function overall. So all these arrows there, we know that at my two turning points, my f dash of x is going to be 0, or my gradient there is going to be 0. It's going to be flat. And as it approaches this asymptote, we know that it's never going to cross over it. So my gradient is going to get flatter and flatter and flatter. So we can say that my f dash of x is going to approach 0. And that's going to be important for later on. For now, we're only interested in when the graph is negative, so we're looking for when the graph is decreasing. That's when my arrows are pointing downwards. So my arrows are pointing downwards, not inclusive between -1, because my graph would be just flat there, my gradient's flat, not decreasing, and 3 for the same reason there. If we have a look at part II next, it says, what happens to f dash of x for the larger values of x? So as x is increasing here, what is happening to my f dash of x? So I'm having a look at what is happening to my arrows. We said that my arrows become flatter and flatter. We know that as a gradient becomes flatter and flatter, it's approaching 0. So we know that my f dash of x approaches 0. But it never quite gets there because it can't actually cross that x-axis, that asymptote. Okay. Now for part II, we have to culminate all this information together to sketch the derivative graph there. So y is equal to f dash of x. So let's have a look at how we can apply that knowledge from the table here. So like we were saying here, we know that f dash of x is going to equal to 0 at these 2 points where the gradient's flat, where I have my turning points. Here I have a maximum turning point, so we know that a maximum turning point goes from below to above the x-axis. So I know that I started off increasing, other way around, so it goes from above to below. So I know that I started off increasing and then I want to go to decreasing. I can see where my point of inflection happens. So I'm going to see where on this line here my gradient changes about here. And that's going to be my minimum value before it goes back up to 3. Then I can see what's happening here. I see from this point here to this point here, I have another change in concavity around here, where my concavity is changing from one side to the other. So therefore I'm going to have another maximum value there. And before it starts to go and approach 0, see how my graph is approaching 0 here? I actually have an asymptote. Because we said it approaches 0, it never quite gets to 0, so I can't ever say that my graph is going to pass that x-axis line. So it's super important that I've got an asymptote that it never crosses there. So that's how we combine all that information to answer a curve sketching derivative question. If you remember all those key points and kind of think about applying your knowledge of differential calculus into curve sketching, that's going to help a lot to answer these kind of questions. Okay, hopefully that video helped.